The topic for Lesson 1-1 is variables and expressions. You'll learn to write mathematical expressions for verbal expressions and write verbal expressions for mathematical expressions. They connect this to a real-world problem by asking what expression can be used to find the perimeter of a baseball diamond. A baseball infield is a square with a base at each corner. Each base lies the same distance from the next one. Suppose S represents the length of each side of the square. Since the infield is a square, you can use the expression 4 times S or 4S to find the perimeter of the square. In the algebraic expression 4S, the letter S is called a variable. In algebra, variables are symbols used to represent unspecified numbers or values. Any letter may be used as a variable. The letter S was used above because it was the first letter of the word side. S tends to be a less than desirable variable because people make 5s look like S's, but back to we go. An algebraic expression consists of one or more numbers and variables along with one or more arithmetic operations. Here are some examples of algebraic expressions. So we have 5x means 5 times x. 3x minus 7, 3 times x, subtract 7. 4 plus, we call that p over q. So that means p divided by q. Fraction bar means divide, of course. This one's less than desirable. We don't usually use the little x for times anymore in algebra. Awkward. Anyway, going on. This would be 3 times a times b divided by 5 times c times d. In algebraic expressions, a raised dot or parentheses are often used to indicate multiplication, as the symbol x can easily be mistaken for the letter x. Here are several ways to represent the product of x and y. So this is the most common, right next to each other, x times y, center dot, raised dot, x times y, parentheses, parentheses, parentheses. In each expression, the quantities being multiplied are called factors, and the result is called the product. The first skill we said we're going to work on in our objectives was to write algebraic expressions from verbal expressions. So let's try that. Write an algebraic expression for 5 less than a number c. So less than implies subtraction, it's getting smaller. So we start with the number c, and then we need 5 less than that. Unfortunately, in English, the order is reversed, so a lot of people want to write 5 minus c, but remember, if we want to be 5 smaller than something, it needs to be the number first and then subtract c. Next, they ask us to write an algebraic expression for the sum of 9 and 2 times the number d. Well, sum is the answer when we add. So it's just going to be 9 plus 2 times the number d. And to write 2 times d, we just have the coefficient 2 right in front of the d. I know they have the same thing written in words. Sum implies add, and times implies multiply. So our answer was 9 plus 2d. Write an algebraic expression for 2/3 of the original volume v. Okay, every time we see the word of in a word problem, we think times, and I use the little x, even though I say we try not to use it in algebra. I'm a big old hypocrite. Okay, I won't write it that way when we write it out. So 2/3 of the original volume v. So 2/3 times v. And there it is written out. The word of always reminds us multiply. A little old-fashioned x for times. An expression like x to the n is called a power and is read x to the nth power. The variable x is called the base and n is called the exponent. The exponent indicates the number of times the base is used as a factor. So 3 to the 1 means 1 factor of 3, 3 to the first power. 3 to the second power, 3 squared. 3 to the third power, 3 cubed. 3 factors of 3. 3 to the fourth 4 factors of 3. Okay, now we're getting a little creative. We have 2b to the 6th, so that's 2 times b to the 6th power, which means we have b used as a factor 6 times. Now they're getting really creative. We have x to the nth power. So I don't know how many factors of x there are. There are n of them. So, and by definition, for any non-zero x, x to the 0 equals 1. I have no factors of x. When no exponent is shown, it is understood to be 1. For example, a is the same as a to the 1. I have one factor of a. Write the product of 3/4 and a to the 7th power algebraically. Okay, product again is the answer when we multiply. So that's going to be 3/4 a to the 7th. A little European 7 there. Write the sum is the answer when we add, of 11 and x to the 3rd power algebraically. So 11 plus x to the 3rd power, or they could have said x cubed. To evaluate an expression means to find its value. So to evaluate 3 to the 4th power, we're going to have 3 used as a factor 4 times, which using the, I'm going to use the associative property here, 3 times 3 is 9, and we know 9 times 9 is 81, so we don't even need a calculator to evaluate that. Very nice. And of course we know 8 squared is 8 times 8 is 64. Should have had that one for a very long time. Okay, the last thing we need to do in this lesson is look at moving to writing verbal expressions from algebraic expressions. They ask us to write a verbal expression for 8x squared over 5. Now, I said that purposely in a way that would not be a great way mathematically. It's accurate. Instead of over, we know the fraction bar means divide. So we could say 8x squared divided by 5, or we call the answer to a division problem quotient. So we could say the quotient of 8 times x squared and 5. Write a verbal expression for, and I'm going to give you one because I'm reading it, y to the 5th minus 16y. That could also be written, the difference is the answer when we subtract. So the difference of y to the 5th power and 16 times y. So it's interesting on the writing verbal expressions because there are several right answers. In summary, variables are used to represent unspecified numbers or values. An algebraic expression contains letters and variables with an arithmetic operation.